All right, we are at 2 p.m., so I guess we will go ahead and get started if everyone's feeling rough and ready. Okay, awesome. So thank you, FinTech DevCon, first of all, for having us. You are here at our talk. Hopefully this is the correct title that you were expecting, From Basics to Best Practices, Why Developers Should Adopt GraphQL. I think a good way to think about this session is that it's kind of a crash course in GraphQL. So we're going to start you from 0, and we're going to go to hopefully about 60, but we're going to cover everything from the basics into implementation, adoption, authorization, even error handling, right? So we're going to cover as much ground as we can, and it'll be in pretty broad strokes, but we'll get as technical and specific as possible. All right, first up, some introductions. Hello, nice to meet you. My name is Lucy. I am a developer advocate, formerly a software engineer, mostly on QuickBooks. Nowadays, I work on API platforms and open source for the most part.
Hello, everyone. My name is Suresh Muthu. I'm a principal engineer at Intuit, and I work on the Intuit Data Exchange platform. We are responsible to get the data in from outside to Intuit products, including the financial institutions. In the past, I used to work in a startup where I had the opportunity to build systems from scratch, making the systems talk to one another through APIs. And most of my learnings come from that experience. And in the past time, I like to ride my bicycle, a road bicycle, in the sunny, sometimes cloudy California.
All right, I'll be taking over the first half, so I guess if Suresh wants to take a seat, you're all in my clutches now. Can I get a show of hands? Who here is like totally new to GraphQL? Like you've thought about it, maybe thought about learning about it? Okay, we actually don't have that many beginners in here, but if the rest of you are willing to give everyone a moment to catch up, I'm going to take you all through a GraphQL 101 first up. It won't take too long, I promise, and we'll do a live demo, actually. I have a demo service running. And then we'll talk a little bit about why we choose GraphQL, specifically, actually, how you choose between REST and GraphQL, right? Because that's mostly everyone's decision you're going through. We'll have a case study, Intuit-specific case study, of how we decided to implement or migrate to GraphQL and where we didn't choose to migrate. And finally, some of the challenges we faced during adoption. There are many. We'll talk about them and how we dealt with them. First of all, though, quickly, if you are not familiar with Intuit, who we are, Intuit is a global financial technology platform. It is also the 4 products, the builder of these 4 products that you see, TurboTax, Credit Karma, QuickBooks, and MailChimp. We do service 100 million customers worldwide, and you will see that evident in our GraphQL numbers, actually. So these are from TaxPeak this year. 1 billion requests per day, 19,000 per second, 2.2 thousand clients, and 100 plus subgraphs. Again, this is from TaxPeak, so actually the numbers probably have gone up since then. But the important thing to note here, I think these are big, impressive numbers, right? I hope. It's actually only 2% of our overall API traffic. So, I mean, I mentioned we have 100 million customers. There's a lot going on through our API gateway. GraphQL is a small little itty-bitty percentage of that because we are also only just getting started on our GraphQL journey. We're also quite fresh, so we're here to share our early learnings. Hopefully we can partner with some of you and learn together as we move forward. But let's start at the beginning. So with GraphQL 101, for anyone here, the 5 or so people I saw raising your hands, we'll start with nothing. I'm assuming, actually, that everyone is familiar with REST. So let's imagine, in this example, that you are building a blog. And so you need to be calling information about the blog posts, the comments on those posts, and the authors of those posts. So in the REST world, you would call /posts, /comments, and /authors 3 different endpoints to get all of the data you need to render your page. In the GraphQL world, it would all come through one single endpoint, actually. I don't know how it's arranged on the back end, right? That's up to you. But the actual service call is going through a single /GraphQL endpoint. At its root, that's all GraphQL is. It's actually just that simple. And obviously, there's a lot of complications there. So let's talk a little bit more detailedly. What exactly is GraphQL, though? When I first heard it, I thought it was like a database technology because it sounds like one. It's not. It is a query language API. The services that make this query language possible can be written in any language. At Intuit, we're actually a Java house, so we use Java Spring Boot. It was open sourced by Facebook way back in 2015. So it's actually been around for a little while, but I would say it's like finally starting to really pick up steam recently. Let's take a look at what a sample query looks like. So on the left over here, this is an example that I actually pulled off of GraphQL.org. I don't know what it's like at your companies, but at Intuit, we really like making Star Wars references. And so I was very delighted to see that GraphQL.org actually also has a lot of Star Wars references. So over here, this is called the root object, and the operation is query over there. The queries, we're kind of like giving it a name. We're calling it hero name and friends. Out of that, we're selecting the hero field. Out of the hero object, we're then selecting the name field and the friends field. The friends field then has more nested fields, which includes name, which is what we're calling for here. You'll see that in the response, the shape of the response directly matches, actually, the shape of the query, which is one of the main charm points of GraphQL. And because the shape so closely matches the result, you can predict what the query is going to return without knowing that much about the server. But you still need to know, what are the data that I can select? What are the fields that I can select? What kinds of objects do they return? And what are the fields on those sub-objects? So that is where the schema comes in. The schema is defined by, surprise, surprise, the schema definition language. It describes the shape of your data. You can think of it as an API spec, basically. And so the schema just describes what's the data that I can get. So this example on the right is the example I'll be running with for the demo also. So, we're Intuit. We work with small businesses. I would like you all to imagine that you are a small business and you have customers and products, and customers are placing orders for those products. So those are the three objects that we are defining on the schema. This example here, I have only 3 object types, basically. The schema is also used to define queries and mutations. So we'll see a live demo together in just a moment. I also want to show you, though, how we connect the schema to actually getting the data. So that's where the resolvers come in. In the DGS world, which is what we use a library called Netflix DGS to handle all of the boilerplate, basically, for doing a Java Spring Boot implementation of a GraphQL service. There are a lot of, you can implement in basically whatever language you want. It's totally agnostic, but that's just what we do at Intuit. So in the DGS world, it's called a data fetcher. We're already familiar with the schemas on the left, but I did add a query at the top. So I sliced out just the customer type definition, and then we have a customers and customer by ID query at the top. You can see that the customers query is, I think it's pretty readable, right? Like it's returning an array of customer objects, and then the customer by ID query is taking a required integer ID and then returning a single customer object. Over on the data fetcher side, we have then routed, linked together the customer by ID query with the customer by ID query in the schema by using this DGS query annotation. So that's what DGS is providing for us, so that I don't have to go and write all of the service implementation boilerplate code. OK, I'm going to quickly show you what this all looks like live. So 1 second. I have it all here. So let's take a look at what a fully formed, this is a very basic example, but what a fully formed query and resolver might look like. So in this case, schema and resolver might look like. On the left, we have the schema. We have the query types at the top. I have mostly customer-based queries. I have a customer type, a product type. This annotation is actually for federation, which we'll get into a little bit later. We also have an order product schema definition here because it helps with a many-to-many relationship. And finally, you'll notice that there are mutations at the bottom as well. Over on the right side, you can see them all connected, actually. So let me scroll up and show you the messy part. This is all mock data. It's not real. You'll see it in the query in a moment. This is the simple, basically, get customers call, right? So it's returning all of the customers that I've mocked up above. The customer by ID is just doing a simple stream filter. And similarly, customer by name and add customer. And these annotations are where everything is connecting everything together. One cool thing I do want to point out as an example, this is actually part of a workshop that I run for beginners at Intuit. This at DGS data annotation is an example of where we are able to do optimizations actually on GraphQL. So in this case, it's defining, it's connecting rather, this with a specific field on the schema. And it's saying, the annotation is saying, don't run any of this unless the person is, the client is actually querying for this specific field. And then you can run whatever you have defined under that method. So just an example of an optimization. Let's actually go ahead and let me show you what it looks like. I find that this helps it with REST developers especially, helps click in their heads. So this is just Postman. We're all familiar with Postman. This is comfortable territory. Notice that it's a post, and it's all to /GraphQL. So I'm not doing /customers, /orders, /products. It's all just post requests going to a /GraphQL endpoint. And I'm calling a get customers query here, where I'm asking for the ID and name of all of the customers available. So we'll hit send, and then the results come through right here. It's really quite simple. Postman is an option. There's also actually additional tooling that Suresh will show you later available in Postman. The other thing I want to show you is something called GraphQL. This is a much more, marginally more complex query is also a get customers call. This time I'm calling for a lot more fields, subfields. And GraphQL actually functions as a sort of built-in explorer. So you can come in here and see what queries and mutations are defined on the schema directly. So it's a very readable, user-friendly view. OK, so that's just to give you a sense of what the tooling might look like. I can't find my cursor. OK, here we go. So the next logical question, now that you know what GraphQL is, how do I choose? We're not here to make the argument today that you should use GraphQL for everything. That's not even what we're doing, right? So how do you decide between GraphQL and REST? Some pros and cons for each. Let's go through those pros and cons lists a little bit. For REST, the strongest benefit, in my opinion, is familiarity. People know how to use REST. You don't have to worry that your developers, like using your APIs, are going to not know how to call your API if you have a REST API. In the GraphQL world, I would not take that for granted yet. The other huge thing is predictable scalability, and you'll hear us bring this up again and again through today's talk. The biggest thing is that when you make a REST call, you know pretty much exactly what the load is for the service. It's the same thing every time, basically. But for GraphQL, that is not the case. You don't know exactly how much data the client is going to query for, and so everything is a little bit, there's some variety, some variance in the data load. So that's a big thing to think about. Over on the con side, you'll always hear people talk about over and under fetching for GraphQL. Rather REST versus GraphQL. And in the GraphQL world, it's much less of a concern. I think everyone can feel the pain point when it comes to REST on that side. And personally, as a former front-end focused developer, I really did not enjoy the part where every time I needed to, whenever there was like an API update coming through, I had to wait for the service developers to like implement the new contract before I could really make my front-end changes. And so in the GraphQL world, because of the added flexibility, that's not as much of an issue. Let's talk about GraphQL also, though, because it's not perfect. It does reduce over and under fetching. It also is huge in terms of the flexibility and we're not talking about best friends forever here, but it is, if you're already doing backend for front-end development, then it's an easy drop-in replacement. On the cons, though, as we already mentioned, there's less predictable load, and also the complexity in terms of migration is very high, which we have a lot of slides to cover. We had a very specific migration strategy that we're going to show you. The adoption curve is very difficult because of that, but we'll show you, don't worry. And finally, throttling and authorization get a little complex when it comes to GraphQL, but we have an authorization expert here, actually, with Suresh, so he'll be taking you through the details of how that works as well. All right, if you guys are ready for our Intuit case study, I would like to welcome Suresh.
Awesome. Thanks, Lucy. Deciding when to use GraphQL versus REST API is one of the important decisions that you will need to make early in your API development program. And we will talk about Intuit's GraphQL journey and adoption, and we will share some of our learnings, which we hope you will find useful for when you are going to GraphQL from REST APIs or even gRPC. And we will also cover some of the considerations that help us decide between REST and GraphQL. We will cover our use cases, the use case study, and break it down into 4 main areas. We will cover the use cases that we found GraphQL to be useful and where we wanted to have REST or gRPC APIs in our ecosystem. And we also talk about the migration strategies that we used when we are going to GraphQL. And in the REST world, there are a lot of tools for the consumers to use it. And we will share some of the tools that we found useful during our design and development phase of GraphQL adoption. And we will try to summarize the best practices for adopting GraphQL. Before we jump into the case study, want to talk about the API traffic. The API traffic will also play a major role when you are deciding between GraphQL versus REST. What is an API traffic? There are 2 main types of API traffic. Some of you may be already familiar with it. There's north-south traffic and east-west traffic. North-south traffic is like the traffic that enters and exits your city. It is the public communication, it's the external communication. It's the inbound traffic where your clients or applications calling your services through the API gateway. And outbound traffic, through your API gateway, you are making a call to your dependent systems, external dependent systems. It could be like a payment processor or the data that you are acquiring from your data providers that's going from your systems to the outside. That's outbound traffic. And these are the kind of traffic you open to outside, traffic from your from public to your application. The east-west traffic, on the other hand, is like the traffic within your city. Right? It is for internal communication. It is the private APIs that you use. These are the kind of APIs where your microservices talk to each other. It could be like within your network. These are your typically internal or private APIs that are used inside your organization. Understanding the distinction between the north-south and east-west traffic is crucial for API security, API performance, and overall API management. Lucy talked about the pros and cons of REST and pros and cons of GraphQL. But how do you decide when to use what APIs for your use cases? So the choice of using REST versus GraphQL or gRPC really depends on your use cases. Could be that you can stick with REST APIs that you have already in your environment that your clients are using, or you could completely move to GraphQL, or utilize them both wherever you find appropriate. So the choice really depends on your use cases, like, is this going to be a new API development? Or you already got the investment going in REST APIs and you want to explore GraphQL, and you want to make GraphQL because of its flexibility it provides. What are the efficiency requirements for your clients consuming your API and your products? Or what is your adoption strategy? Can GraphQL API coexist with REST APIs for some time while your clients and consumers are moving to GraphQL? And mainly, is it for internal or external communication? The north-south versus east-west traffic that we just talked about also plays a major role in deciding whether you want to use GraphQL or REST or gRPC APIs. Let's talk about the north-south communication. For north-south traffic, GraphQL was a clear winner for our use cases. It's completely based on like how we are planning to use our APIs. Because the better job we do at exposing our domains and the capabilities of our domains, the more autonomy this gives our consumers to consume the data in the form that they want. And this, in turn, has the beneficial side effect of freeing up our engineers so that they can concentrate on other areas in the backend development system. Because they no longer have to wait for the backend engineers to change the API contract. Once you define a solid set of APIs and the attributes that can be aggregated across multiple domains, GraphQL provides a lot of flexibility for you to choose, for the clients to choose what we want to consume, especially for mobile clients, where the network traffic is very important. For our east-west traffic, REST or gRPC is the path we have retained. This is primarily due to the fact that these communications are fairly well established. And one of the downsides, the cons of GraphQL is we cannot predict the load patterns. And for our APIs that are extremely high in volume, like an authorization call, where you have to make tens of hundreds of millions of calls to millions of calls a day to have the allow or deny decisions, gRPC or REST API is the best fit. And also, we want to be able to scale with predictable load pattern, especially during our busy seasons. We also want to have a high degree of reliability and stability depending on the load patterns during our peak season. So we are using REST APIs for those use cases. And the east-west traffic is the kind of traffic where you don't want to facilitate a sudden shift in your API contract unless both sides, both the API producer and the consumer have agreed to or understand the need for and the impact of such a change, and they coordinate together to make that change. Authorization is a very good example of using REST gRPC APIs for east-west traffic. So here's our latest approach. We use GraphQL for north-south traffic and REST or gRPC for our east-west traffic. Let's get more details, little deep into GraphQL. Just to set a little bit of context, if you're not super familiar with the GraphQL in a larger organization, I want to share some terminology. As you start, in a startup, you may have a single GraphQL API if you're choosing to use GraphQL as your API. You may have a single GraphQL API instance, and that's absolutely fine. And you will probably refer to them as your GraphQL API. But as you grow, or if you are acquired or acquire another organization, now you may have more than two or more GraphQL APIs. In that type of scenario, we refer them each of those GraphQL instances as the subgraphs. And joining multiple of these subgraphs into a single graph is going to be referred to as a supergraph. Creating a supergraph out of many subgraphs can be accomplished via federation or schema stitching. We won't go into the details of the federation or schema stitching, but we can talk afterward if you want more details on that. Within Intuit, we decided to use GraphQL for our specific use cases, and the federation was the path of having a supergraph. And one of the early questions that came up was whether to have one supergraph or multiple. What we settled on is to have a single GraphQL schema registry where we register all the subgraph schemas, where our domains and capabilities. Subgraphs are registered with a single GraphQL schema. Having a single GraphQL schema also allows us to identify any duplicates. If the two domains are providing similar or equivalent functionality, we will be able to identify that with a single GraphQL schema. And also, we will be able to identify any common types or common set of APIs that are required across these subgraphs, the GraphQL APIs. We will be able to identify them and leverage or move into a common type, especially the types, and register that in the schema registry. But when we are registering each of this subgraph schema into our common registry, we will also tag the schemas. So it identifies like which part of the subgraph of the domain the queries and mutation and types are coming from. And having all of these types in the schema tagged in our schema registry allows us to build supergraphs based on our customer needs and also what's tagged in the schema we want to include. This allows us to dynamically group the products, group the capabilities, and make it available for our consumers for a particular use case, and carve out multiple supergraphs in a single schema registry that we have established. Let's talk about GraphQL migration. There are a lot of learning curve, and like both from API producer side as well as the consumer side. And Intuit is a 40 years old startup. We have a lot of REST APIs and gRPC APIs in-house. And when we decided to have GraphQL as our new set of APIs, we needed to have a migration strategy when adopting GraphQL. We will share some of those learnings, and we hope you will find them useful. Let's talk about the GraphQL Gateway Supergraph. The capability subgraphs can source the data from multiple integration methods, as Lucy was showing in the example where the resolvers can get the data. If you have, so the capability subgraphs can source from multiple methods. Like in the first capability subgraph one, it can implement a new direct service where it can have a database. So the resolvers are directly getting the data from that service and making it available as part of the GraphQL gateway. Or you could have an existing downstream services. It could be REST or gRPC or even GraphQL API. And you can have the data, the resolvers go to the existing downstream services, get the data, but make it available through GraphQL. Or you can have a combination of both. You can utilize both approaches. We call this a stepping stone strategy, where we leverage our existing services and layer on top of the existing services, provide GraphQL API on top of it. If you are starting from scratch, you can go with capability one subgraph, because it's a brand new development. You can implement your GraphQL APIs and the service implemented. But if you have an existing service, you can also start layering on top of this, implement new. And also, eventually, you can phase out REST API if you are completely deciding to go with GraphQL. Let's talk through an example of how replacing a REST API that you have in your ecosystem with GraphQL. This could be your starting point. This could look like what you have right now if you're using REST APIs, where your clients are accessing API gateway and through the REST service. And the REST service could have dependent services inside your organization, like database or another service, et cetera. The first thing that you would want to do is to separate the API layer from your service layer. Move the business logic from your API service into a service layer. You want to keep your API layers thin as possible. As you are moving to another API, let's say GraphQL, you could start leveraging the service layer instead of duplicating all of that code in your GraphQL API service. So we want to carve out the API layer, keep all the business logic in the service layer, move just the API layer to APIs to the API layer. In stage 2, you could introduce the GraphQL API layer. We talked about the supergraph. You can part of a supergraph and expose that to a select customers, the clients, through API gateway. And the dependent services systems will remain the same. And since you have already abstracted out the service layer and the business logic into the service layer, you could easily use the same functionality exposed as GraphQL APIs for your existing capabilities. And when your clients are ready and you got enough early feedback on that and everybody is ready to move, you can completely replace your REST APIs, use GraphQL APIs, and use the service layer that you have created, and that will go to the supergraph, and all our clients are consuming the GraphQL APIs now. And REST has been around for a while, and we have a lot of support, especially around the tooling. I'm sure everybody is familiar with Swagger kind of tools where you can, for both design and development time. But when it comes to GraphQL, the tooling support is still limited. It's being worked on, and it is getting a lot of presence in the market, and it is getting ramped up, but it is limited. And we would like to share some of the tools that we found useful and we have utilized for GraphQL. The first tool I would like to introduce is the mocking library, the GraphQL mocking library from the GraphQL guild. And it's part of the GraphQL tools tool set. GraphQL is strongly typed, and it allows you to have mock responses to be automatically generated with this tool. And you can have, when you define the schema, you can give this to your potential customers, get the early feedback before even you start writing the implementation. You can use the marking library to give it to your clients and also to see what APIs are, what queries and mutations are needed, and what are the attributes that you are going to expose as part of this GraphQL API. The other tool that I found personally useful during GraphQL API service implementation is Postman. Lucy did a demo on that as well. With Postman's built-in GraphQL support, it allows you to compose the GraphQL schema through introspection, or you can upload the schema file as well. We will talk about the introspection and the security aspect of it in a minute, but during the test and the design and development phase and the testing phase of your service, you could use a combination of the mocking library. You can just define the schema, give it to your consumers, and also load the schema in Postman and have them play around with the queries and let them define the shape of the query to get early feedback. It could be like I have all the attributes that I need, or like I'm missing this attribute, so you can define the set of attributes that suits your customer needs. There are a few more tools that we found useful. GraphQL is one of them. You can embed that in your service, make it available in your environment. Your clients can use it, explore, shape the GraphQL queries. And it's also part of Netflix GGS. It comes out of box. You can enable that. As we went through our GraphQL journey, we also defined a set of best practices and guidelines that suited our needs. Things like naming conventions. Right? And we used a linter, open source linter to call GraphQL schema linter, and defined our own custom rules for our API guidelines and best practices. We implemented through an IDE plugin or a tool, and you can integrate in your PR, in your Jenkins part of that. So you can use all of this as you are developing GraphQL schema and validate the naming conventions that you have established and the best practices that you have established for this. And Intuit also has some of the open source libraries that are available specifically for GraphQL, including the GraphQL quilt. I'll cover some of the best practices that we found useful when we were migrating from REST to GraphQL. When an error occurs in REST request, the HTTP status code tells you a lot about the error even before you read the error message into it. For instance, 403 forbidden, you immediately know that there was an attempt to access the resource, but the access was denied. Then the error message provides additional context and additional information, like the requester does not have the proper role. But GraphQL is transport agnostic. It's typically over HTTP, but it isn't necessary so. That means GraphQL does not rely on HTTP-specific features such as status code or error code. And the GraphQL spec only requires an error message in case of an error. So the GraphQL responses are almost always going to be at 200, even in case of error. So that impacts how you are going to have your error handling, both in the client side, but more importantly, how you are going to handle your FCIs, your failed customer interactions. What are your triggers for golden signals? What are your alerts to incidents? Observability in general. You want to pay attention to these and incorporate as you are going to GraphQL. Let's talk about security and GraphQL security in particular. Over the last couple of years, OWASP has done a fantastic job in covering what you should be mindful when it comes to GraphQL. At Intuit, we took the OWASP GraphQL cheat sheet and added our own best practices around it on security. I will highlight a few things here. For example, you don't want to auto-generate the schema from your database. That's a bad practice in API in general, but in GraphQL, you could end up exposing the field that you didn't mean to. Instead, take time to understand your use cases and expose the attributes and the APIs in a user-friendly way that also satisfies your customers' use cases. And you want to disable introspection in production as a security measure. It's absolutely OK to have the introspection enabled in your pre-production environment where you're allowing your developers to integrate and quickly identify the issues and introspect the schema, including the GraphQL tool that we saw, but you want to disable in introspection because you don't want to expose the infrastructure, and you have the ability to combine multiple subgraphs, but you don't want to expose the infrastructure to your consumers. And also, you only want to expose your supergraph to your consumers, not the subgraphs directly. Some of the validation that you could do at the supergraph, you won't be able to do if you directly expose the subgraphs. We talked about authentication and authorization, especially on the authorization side of things. You want to keep your APIs layers light so that if you want to have both REST and GraphQL, then you don't have to repeat all of your authorization logic in the API layer. And it will also keep things simple and make your APIs less complex. Just to wrap this up, I want to highlight the importance of having an executive sponsorship for any API program as you start. The main reason is that these things take time. And you don't want to skimp on something that will be so foundational to your organization, both internally and externally, if API is a core strategy for your growth. To do this effectively, you need to work with your leadership to establish what the return on investment will be for this effort, and have clear milestones and deliverables and measurements defined that will keep everyone in sync on where you are going and what you are going to unlock with each piece. The most common justifications for why adopt GraphQL to do all of this is, one, it increases the front-end developer velocity because they don't have to wait for the back-end developers to morph and then leverage the API. They can pick and choose, especially for mobile clients. We found GraphQL to be super useful. And because of that flexibility, it also reduces the amount of work and amount of engineers we need to maintain an API. We need less engineers to maintain the backend API because they don't have to change that regularly, and so that they can focus on other backend areas. Here's a QR code for our Intuit developer community. We have links for some of the open source projects, including the GraphQL tools that we talked about, and also our Intuit developer portal. We would love to get your feedback on that. And I would like to thank the exhibitors and the sponsors for fintech, and thank you for having us here. And there's an app survey if you want to take. Thank you so much.
We have some time for questions, if anyone. Oh.
Okay. So when you talk about creating two supergraphs, do you have any services that can be present in both?
OK, the question was, when you are talking about two subgraphs,
Two
supergraphs,
yeah.
And can the functionality be present in both supergraph?
Yeah, can you have the same tag appearing in both?
Yeah.
Can you have the same service and accessibility?
Yeah, absolutely, right? Like that's the advantage of having the tagging in your schema. But let's talk about like one example, right? If you are providing identity, like when you have to get the identity of the system, and where you want to get the user's email address as an example, right? In two supergraphs, it is possible, right? Like you can have carve out a subgraph and tag it as a common subgraph. But when you are creating a supergraph, you can say, I want this supergraph to have that common identity subgraph, as well as other subgraphs that you are interested in. So it could be leveraged for both. So it also provides a way of reusability. And having a single schema registry allows us to build that. So the combination of the tagging on the subgraphs as well as having a single schema registry, you could reuse some of the APIs. That's a good question. Yes?
How do you address translations of strings? So let's say if I have a service with message in English, translation, and a few more French. Where do this sit in this architecture? Like, does the translation happen in the subgraph or subgraph?
Okay. The question is, you're talking about localization, right? Externalization and localization. How do you localize your APIs in multiple languages? So when you are defining, so let's talk about with one example, right? Let's say you are returning an error, and that error you want to be displayed in multiple languages. Right? Ideally, we would like to have the error schema have the status, message, and the error code defined. And the message could be by default in English. You could return that. But the error code could be specific to that error. And you can enable, if it is your clients leveraging that error code, you can define multiple of these schemas and translate that at the client level. Right? So you are giving the flexibility to your clients to choose the language. And so one of the best practices that we found useful was to have the error schema defined properly, and by default, return English US as a language, but give them the flexibility with the error codes and give them flexibility to the consumers to be able to translate in multiple languages. Yes?
So going back to the point about REST versus Graph and making a decision, I guess on the REST, you kind of like performance, you can control it. You think how expensive operations on the server side are with very well-defined REST services. When you open Graph, you open for the client to call expensive, generate kind of like real expensive operations on the server side. Have you guys seen, like, have you had to deal with that problem where now you have Graph and there's more expensive, you had to more compute or something like that?
Yeah, no, absolutely. That's, I think you are like hitting the hardest problems, right? One of the hardest problems. How do you scale? Sorry, I think the question was like with REST and GraphQL API, for GraphQL API, like in terms of resources, did you find it expensive than REST APIs? Yes, right? But you have to configure it in a way that you're able to scale. One thing is going to be the latency aspect of it, right? But GraphQL has a lot of flexibility around this. You can define the APIs that you are going to use from your clients, from a known set of clients, and have that set of APIs come in, and you are not doing the input validations and other stuff. Because if it is, let's say, you are also developing the client, and you know what the queries are going to be, unless it is, you are making that change. Right? You have that in control. So you can define these things, and you can skip some of these input validations. But when you are opening it up completely, right, that's one of the things that we talked about, the predictable load patterns. So if you think like your service cannot handle that flexibility or the variance in the load patterns, then you want to consider that as one of the factors when you are switching to GraphQL. We can talk more in details, but in the short answer is like you have to pay special attention to it. Yes.
We are more or less at time. I also don't see any hands up. So if any questions arrive in your head, we actually have a booth over on floor 5. I mean, it's right outside. You'll see us. We're the Intuit booth. So we welcome you to stop by, say hi, ask more questions. And thank you for coming.
Yeah, thank you.